Bismillahirrahmanirrahim. Welcome to the channel Math and Abir guys. Today we are doing A-level math and this is the topic discrete random variable and we are going to let's dive in. Okay, so the first question here is from 2020 and this is paper 5-3. Okay, so three coins A, B, and C are each thrown once. Coins A, B are each biased so that the probability of each obtaining a head is 2 by 3. Okay, and they are biased, right? And biased coin is such that it is unfair. It doesn't give equal probability for the different outcomes. Rather, as you can see, it is more favorable towards bringing in a heads than it is in bringing a tails. And same is the case with C. C is also biased, but it is even more biased towards head and it is giving 80% or 4 by 5 probability. Okay, for head. And part A is asking us to show that the probability of obtaining exactly two heads and one tail is 4 by 9. Okay, and this is a question for show command word, which means that you have to show your working to reach this particular answer right here. This is the answer. Okay, so 4 by 9, right? 4 by 9 should be the final answer. So let's think of the possibilities. Okay, if we have two heads, right? So this can be the case and we can list down that A, B and C will be flipped in this order. Okay, and then we can have the other one as head, tail, head. Remember, we need two heads and one tail. Okay, and then finally we can have tail and a head and the two heads at the end. Can you think of some other combination? No, right? So we have T's in three different positions, first, second, and third, like this. And let's write down their probabilities. So keep in mind that A is head in the first one. So A is head is having 2 over 3. And then times B head is the same, 2 over 3. And C is tails. So head is 4 over 5. So the tails of this should be 1 over 5, and similarly the tail of this should be, if you subtract 2 from 3 or you subtract 2 over 3 from 1, so you get 1 over 3, right? So this is tail for C, which should be 1 over 5. Okay, now for this second one, second combination, H, T and H. So H will remain same. T for B is 1 over 3 and H for C is 4 over 5. Okay, for the last one, we have T in the A coin, so that should be 1 over 3, and H in the B and C. H for B should be 2 over 3, and heads for C should be 4 over 5. Okay, now multiplying the probabilities to get 4 over 45, 8 over 45, also 8 over 45. If you add them up, so you should get 20 over 45. Okay, and if you reduce it by 5, so you are going to get the answer that was in the question, and hence you have shown your answer to part A. Now this is for part B. Okay, for part B, they are asking you the random variable x is the number of heads obtained when the three coins are thrown. Okay, so the three coins are thrown and x has been defined as the number of heads. So let's first uh, draw up a table here for the probability distribution, and we will do its working beneath it. So guys, the number of heads can be definitely, if we are having three coins tossed up that are A, B and C, so we can have either all tails, so that would be 0 heads, right? If we have one head, that would be one head and two tails. If we get two heads, so that can be two heads and a tail. And finally we can have all heads, so that ends the possible values of the discrete random variable here. Okay, now these are the discrete values 0, 1, 2, and 3, and you can't think of some other discrete values. We will write down their probabilities here once we have them after calculation, but for 1, I think for 2 we already have the calculation done. No need to redo it, because in part A you were asked about 2 heads. See here, you were asked about exactly 2 heads and 1 tail, and the probability that you have already shown is 4 by 9. Even if from exam point of view, even if you are not able to find this 4 over 9, you can take it up from here in the question. It is written part A, the answer is 4 over 9. As I told you already that the answer would be this. So you can pick it up for your answer in part B, and that's called smart working. So we are going to put it here 4 by 9. Okay, right? Or I can also write it in the 45 form, that is 20 over 45. Why am I writing this? You will get to know in a short amount of time. Okay, now let's do the working for the remaining values of x. So for 0, okay, let's do the working here. For x to be 0 means all the tails, 0 heads or all the tails. So all the tails will be having the probability. As you can see here, we worked out the tails probability. So 1 over 3 for A, again 1 over 3 for B, and then 1 over 5 for C. That will give you 1 over 45. So 1 over 45 you can write here, and that was the reason I wrote this 20 over 45 with 45 denominator, so that I can add them up, or whatever I want to do for verification I can do easily if their denominators are same. You must have got it now. Okay, x is 1 means 1 head, but this will have many possibilities. So what you're going to do here, you are going to list down all the possible scenarios. If you want a single head, so definitely you can have a head in the first place and the 2 tails following it. You can also have a head in the second place in the middle of 2 tails. You can also have a head at the end followed by followed by 2 tails at the beginning, right? So let's find the probabilities. A head means for A, and that is 2 over 3. Don't forget that the first one is A, the second one is B, the third one is C. As we have came up with this, we have come up with this assumption that A is thrown first, and then B, and then C, right? So 2 over 3 for A, and then tail for B would be 1 over 3, and tail for C would be 1 over 5. This will give you 2 over 45, right? Okay, this was for 0, and this is for 1, right? Now you have tail. So tail for A would be 1 over 3 times head for B, that is 2 over 3, and times tail for C, that should be 1 over 5. Finally, it will also give you 2 over 45. And the last one is tail, tail, and head. So tail for A would be 1 over 3, tail for B will also be 1 over 3, and tail for C will be 1 over 5. So you can come up with 1 over 45. Now, if you add these up, so how much do you get? Okay, over here we have one thing. If we have a head for the first one, that is 2 over 3, and then tail 1 over 3, and tail is 1 over 5 for C. Tail for A is 1 over 3, and head for B is 2 over 3, and tail for B is also 1 over 5. That will give you 2 over 45. For the third one also, tail 1 over 3 times 1 over 3, and then times 1 over 5. So it will give you finally this probability. Okay, now what you can do here is, if you have this 2 and 2 and 1, so you can add them up. All right, and you can also find the probabilities using different scenarios. Okay, so if we have just a single head and we can come up with this 2 times 1 times 1, that is this. Okay, and we can also come up with this tails and head. That should be tails and head should be like this. Okay, and the head here I think is 4 over 5. It's not 1 over 5, sorry, my mistake. This is 4 over 5. As you can see, this head right here is 4 over 5 for C. So this should be 4. And now when I add these up, so I get only the numerators I can add. 2 plus 2 plus 4, that should give me 8 over 45. That I can write in the column for 1. And here's the column. So 8 over 45. Now the only one left is 3, and there won't be much of a working in 3 because there can be only one scenario where we can have x equals 3. That means all the tails. So all the tails will be just multiplication of all the tail probabilities. The tail probability for A is 1 over 3. The tail probability for B is also 1 over 3, and the tail probability for C is 1 over 5. That gives you 1 over, uh, that should give you how much? Okay, have we already done for 2? Yes, we have. And for these tails, we have 1 over 3, 1 over, oh, sorry, my bad. We want 3 heads. Sorry, my bad. We don't want 3 tails. We rather want 3 heads because x, remember, was defined as the number of heads. So 3 means 3 heads, all heads. So the first head here will be for A, and that is 2 over 3. Same is the case for B, since they have same probabilities. And for C, the head probability is even more, that is 4 over 5. Once you multiply the numerators, you get 2 times 2 is 4, 4 times 4 is 16, and you should get a 45 again in the numerator, as we have already got the same 45 for each one of them. Now, to verify, always verify the probability should be 1, right? So if you add up 1 over 45, 8 over 45, 20 over 45. Remember, pick up this one. Do not pick up 4 over 9. That will create a calculation problem if you are doing mentally. If you are doing on calculator, it doesn't matter. Okay, 1 and 8 is 9. 9 plus 20 is 29. And 29 plus 16 is, yes, it is 45 over 45. That will give you a 1. So yes, your probabilities look fine. Okay, and the last part for this question is asking you for a variance calculation. They have provided you with the expected value of x, and they are asking you to find the variance, and 2 marks for finding the variance in part C. Okay, expected value is already provided to you, no need to calculate that. Remember the formula for variance that we are going to use. It is also provided in your MF19 formula sheet, and you can just multiply your x values, summation of x squared times the probability, and subtract from this the expected values squared, right? That should be 32 over 15 squared. No problem about that. For this part, we are going to do the long calculation. I think I should start from here. Okay, so you have to square them up. Okay, let's find their squares. If I find the x squared right on top of x, that should be 0, 1, 4, and 9, right? 0, 1, 4, and 9. So I can simply multiply this 0 squared with the relevant probability is 1 over 45, or I can simply write 1 and 45. Since it is 45 for each one of them, I'm going to write 45 just once. I can take it as common. Okay, and then this is 1 times 8 over 45, sorry, 8, only 8, and then you have 2 squared with 4 or 4 with 4, and then you have this 9 with 16. I hope you are clear. I'm picking up these values here: 0 with 1, 1 with 8, 4 with 4, and 9 with 16, right? And then you can use your calculator to come up with the correct answer. That is right here, uh, 136 over 225, or you can also write in decimals. 0.604 is your final answer for variance. That was it for this particular question. Okay, let's move to another question we have here. Okay, okay, so we have this one, and then we have another question here with from the 2020 paper, but this is a different variant. So let's see what the question has. Okay, this is from 2020 and variant is 2, paper 5, S1, right? So winters. Okay, now a bag contains 5 red balls and 3 blue balls. So you can have it like this. Um, why not go with 5 red, and why not go with 3 blues? Okay, 3 blue balls, but this is not clear. We should use a lighter one. Okay, Sadi takes 3 balls at random from the bag without replacement. Okay, without replacement. And the random variable x represents the number of red balls that she takes. Okay, so we have to show the probability that Sadi takes exactly 1 red ball. If she takes exactly 1 red balls, so and when she are picking up 3 balls, so it should be either red should be at the first and then followed by 2 blues, or it should be red in the middle of 2 blues, or it can be red at the end and 2 blues at the beginning. So the probability we can have for red ball, definitely it should be, first you are having red balls, so 5 red balls out of a total of 8. And then since it is without replacement, you can see here, so your total will decrease by 1. You now have 7 balls in the bag, no more 8 because you have picked up 1. So now you have 7, and out of 7 you are going to find the probability for blue. So blue are all 3, but then again decrease 1, it will be 6, and then decrease 1 for blue as well because you picked up a blue in the middle one in the second place. So now you have a blue of 2. Okay, so for this one, okay, now we have for blue, um, it should be 3 over 8. Then again, without replacement means you have to decrease from 8 to 7 and from 7 to 6 the denominator, because it is without replacement and you don't have the ball replaced by some other ball. Now you have red, so 5 reds all are there. And then when we talk about blue again, so you already picked up a blue in the first place, so it should be now it should be something you can say 1 less than 3, that should be 2. Okay, now for the last scenario, so we have first is blue, that should remain 3 by 8. Second is blue again, it should be out of a 7, and it should be not 3 but 2 because you already picked up a blue in the first place. And now for red, the denominator is 6, the total is 6 balls, but the red is all there, all red are there 5. So now you can see the denominators of all of them will be same, since you have same denominators in the 3 fractions. So 8 times 7 is 56, and 56 times 8 times 7 is 56, times 6 should be 336 for all of them. In the first scenario, 5 times 3 is 15, times 2 is 30, again 30, and then again 30. So you have something 3 times 30 over 336. If you want, you can cancel them out as well, and you will have 1, 1, 2 in the denominator. You are left with 30 over 112. If you want to reduce it further, and you will have to, because the answer you can see here is in the reduced form, this answer, right? So it is already in reduced form, so you will have to reduce to show it to the examiner that you know how the working came up. Okay, now we have 15, so we should divide by 2. 2 times 15 is 30, and 2 times 56 should give us 112, and that is the final answer for question part A. Okay, now we also have part B. Draw up the probability distribution table for X. X was already defined as number of, I think, number of red balls. Number of red balls that Sadi picks up. So that had already been defined by the question. No need to define it or get confused about it. So let's draw the probability distribution X, and then probability of X. Okay, the possible values for red, as you can see, you can have all the blues, since there are three blue balls, so it is a possibility that in all the 3 experiments you take up all the 3, so the reds are 0. And similarly, red can be 1, as we have just shown. The probability for exactly one red ball is 15 over 56. Let's copy it down here, 15 over 56, or also write its full form that came out to be 30 times 3, 30 times 3 over 336. So that should be 90 over 336. Let's write this as well as we did in the previous question as well, so it will be helpful for us in the calculations. Okay, red can also take two reds can appear, because we have 3 experiments and we have sufficient number of red balls, so we can also take 2 reds, and obviously we can also have all the reds, that is 3 reds. And the experiment ends here because you have been asked to find the number of red balls that she picks up, and the experiment continues only 3 times, or you can say that she picks up only 3 balls. So 3 is the maximum value of X, and 0 is the minimum value of X, and these 4, 0, 1, 2, and 3 are the only distinct possible values of the random variable X. Now let's do the working for 0. 0 means for X to be 0, it means that you should be having all the blue balls, right? No red means all blue. So for all blue, your probability should be, since they were blue balls were I think 3, and red balls were 5. Let's confirm from the question. Yes, this is the case. Okay, so we have this particular case here. Let's write this here. Okay, so we have red is 5. Red balls are 5 and blue balls are 3. Okay, now B would be 3 over 8 times 2 over 7 times 1 over 6, right? Because you have to reduce 1, so you get 336, and then you get 6 in the numerator. So that should be your answer for this, 6 over 336, right? Okay, now for X equals 2, so we can have different scenarios. Why not do for X equals to 3 first? Because that will have only one scenario. So X equals 3 means all the blue balls, all the red balls. For all the red balls, again, it's going to be a similar calculation as we did for all blues. For all reds, it should be 5 over 8, and then it should be 4 over 7. You have to just decrease 1 from numerator and denominator, because you have already picked up 1 red in the previous instance, and there is no replacement, so the denominator will also get decreased by 1. 5 times 4 is 20, times 3 is 60. So you get your probability for all, like for 3, for x equals 3, it should be 60 over 336. Okay, now we already know for 2, we can, since we are confident about working, we can use this complement formula, that if we subtract the other probabilities from 1, so we can find the remaining probability for 2 right here. So we can do it like this: 90 and 60, 150 and 156. So you have to subtract 156 from 336 and then divide by 336. So you should get 180 over 336, right? So that should be your final answer. Okay, so now we have this to 180 over 336, and you can always tally the numerators, add them up, so they will definitely give you 336. That means that your probability is coming out to be 1, and it should come 1 in this case, because it is already provided that this was 90. This is that we use this complement formula for probability. We subtracted for 1, right? And to find the probability that x equals 2, we use this shortcut, and rather than different scenarios of 2, we use this shortcut and came up with this particular answer. Okay, now we have the probability distribution table. We got the 3 marks, and the last part of the question is asking you for, again, it's providing you the expected value of x and asking you to find the variance of x, as was the case in the previous question that we solved in this video. Okay, now the expected value is provided to be 15 over 8. By now you must be having the formula of variance of x in your head, and that was summation of x squared times p. Subtract from that the expected value of the square of expected value of x. Okay, now, so in order to, okay, this we already know, 15 over 8. Some people are confused why it is more than 1, since 15 over 8 is more than 1. So it can be more than 1, no problem about that. Only about probability, we said that it should not be something that you can say that you can say it is more, it can't be more than 1 for probability. We only said for probability that probability is always in between 0 and 1, and we didn't say any such thing about expected value of x or variance of x. Okay, now, so in order to find this x squared times p, we need to take the squares of the x values. Our x values are right here, so let's find their squares. On top of them, it should be 0, it should be 1, it should be 4, and it should be 9. I'm going to multiply this with this with this, and this with this, and this with this. Why? Because I will take 336 as common for all of them. So write that in just one go, and 336 will be here. And you can just multiply 0 with 6, 1 with 90, and 4 with 180, finally 9 with 60. So that should give you your final answer, and it should give you 90 plus 720 plus 540 over 336. Subtract from that the square of this, which should be this, and once you find this out on a calculator, it is giving you this answer, 136 over 225. Or you can also say, okay, sorry, this is coming out to be something else, and this is coming out to be 225 over 448. right? Okay, yes. So okay, so now we have this particular um, okay, so the particular answer for this is coming out to be 225 over 448, or you can also write in decimal to 3SF 0.502. That's your final answer for this particular question. Hope you gained something out of it. Do remember to share your thoughts in the comment section below, and please consider liking and sharing, subscribing to the channel, liking and sharing the video to your friends, and seeing you in the next video. If you have any suggestions for content, please write to me, and see you in the next video. Bye for now.